Hello, folks. I hope you're all fine. My name is Tom. I'm product manager at Waylay. And today in this webinar, I'm going to talk about a new module that we've added to our portfolio, which is called the Bring Your Own ML module. But before I explain that, let me explain the bigger picture first. So Bring Your Own ML, as the name says, it has to do with analytics. Waylay really focuses on how to operationalize analytics. Well, what does that mean? It basically means that our platform enables you to basically productize the smarts that you have with respect to your algorithms on processing IoT data and operationalizing it, so putting it into production such that it really generates the necessary business benefits, and in particular that you can actually take actions out of the algorithms that you may have already designed. Okay. So Waylay has various capabilities to operationalize these analytics. If we start from the left-hand side, the Waylay's automation engine is ideally suited for semi-real-time analytics, in the sense that it's ideally suited to implement expert knowledge or heuristics that typically already exists within a customer's environment. So we're typically talking about existing procedures that may not have been automated, where Waylay can really play a role in automating that data processing and basically take actions accordingly, such that there's no longer a need for manual evaluation of the data. And so typically the automation technology that we provide, the streaming automation technology, is ideally suited for this expert knowledge that can come in all sorts of forms. It could be, for example, algorithms that are standardized for a particular domain, for example, in the building automation or around energy management, or you may already have some heuristics based on previous knowledge that exists within your team or within the support team that you may already have. So that knowledge can typically be captured in the existing rules engine of Waylay. Next to that, we also have a module called Waylay Time Series Analytics, which is a citizen analytics type of module that allows customers that do not want to bother with building their own algorithms, but use Waylay's tool and wizard to automatically create a model for the data that they're capturing. And the typical use cases here are about anomaly detection or doing predictions on it could be any metric, temperature or energy consumption in a building, or vibration data, anything that is evolving over time. It's really focused on time series analytics, and with a couple of clicks through this wizard, you can let Waylay figure out what is the best model using a large library of statistical models that we cover with our platform, to model the behavior of these metrics, and then you can use the time series analytics to design that algorithm, test that algorithm, and ultimately jump back and forth between the design of that algorithm and the rules engine that is going to take actions whenever an anomaly is fired or a prediction is made, time to target predictions, for example. Typically, this is used by customers that do not have a preferred time series analytics platform, or do not have a large team of data scientists available such that they can basically leverage Waylay's automation capabilities there to automatically instantiate such models. Okay. The topic of today is a third option, which is the right-hand side of this picture here, which is called Bring Your Own ML, where I want to make a distinction between customers that may have already built machine learning or AI algorithms that are either running within their own framework, for example, Azure ML or SageMaker, for example, or customers that prefer to use Waylay as the environment to host that model. Okay, but what both approaches have in common is that the training of the algorithm happens outside of Waylay, typically within the data scientist tool of choice. Okay. So what is the difference between the third module and the first two ones is, well, first of all, Waylay does not see the source code of the algorithm. Okay, so some customers want to hide that from the Waylay platform, and when Waylay is requesting an execution of that algorithm gets executed without having a view on the actual implementation. Okay. And clearly, like I said, the algorithm needs, of course, to be trained, needs to be configured. And that typically happens outside Waylay as well. While in the first two approaches, training can happen in Waylay's environment as well. So clearly, the third option, the bring your own ML approach, is aimed at the data experts that have already made investments into algorithms and want to leverage that in concert with Waylay's automation capabilities. So during this webinar, we're going to talk about the two approaches. And we'll start with the first one, which is showing how Waylay can interface with an external AI framework that is hosting a machine learning algorithm, and we'll use Azure ML as an example on how to interface with that. On our documentation page, we have other examples as well, like SageMaker, for example. So if you go to this link, there you will find the description of the different options where either Waylay can host your model. I'll come back on that later in this webinar, but also how you can interface between Waylay's rules engine and an algorithm that runs on AWS SageMaker, for example. For that, we have introduced new sensors, a SageMaker sensor, and in fact, we've also provided an example rule that you can download from GitHub that you can explore a little bit on how it works. But here you see, for example, the icon of our SageMaker node that you can drag and drop into your rule using the rule editor. And you also see some description on what you need to configure. Okay. Similarly, for Azure ML, we have similar nodes that you can use within your rules, and that is something I'm going to demonstrate right now. So let's get back to the presentation here. So the use case that I wanted to highlight is a use case where we're using Azure ML to host an algorithm that is processing image data. So the use case here is where we are using Waylay to orchestrate a computer vision or a machine vision use case where you have, for example, a camera capturing an image that could be a camera, for example, on a production line that is monitoring the output of the production line visually to check whether the production line is performing as it should, right? It's just validating. In our case here, we're using an example from the web that is processing images of a wooden board with a number of screws. And if the production line is performing as it should, then there should not be any holes, and there should be 4 screws in that wooden board. Okay. For those that are interested on the code that we used to create that algorithm, well, this is the location where you can find the TensorFlow algorithm that we've trained on Azure ML and also hosted on Azure ML. So if you click on this one, you'll end up here on this GitHub repository, where you can find the actual algorithm that it uses. We didn't build it. It's something that is publicly available, but this repository also contains a few data sets that you can use to train and validate the algorithm itself. Okay. So what are we using Waylay for? Well, Waylay is basically going to orchestrate the machine vision use case, which basically means that when the camera indicates that it has an image available, we are going to, and that image is available on a certain location. That could be, for example, an S3 bucket, or could be any storage location. So the URL to that location will be fed to the algorithm, that the TensorFlow algorithm that is running on Azure ML. Azure ML will process that image that is on that location and will basically output a number of things, which we then further process in the rule to evaluate whether the production process is behaving as it should. What does the algorithm output? Well, it outputs what you see here on this picture. So it outputs, on one hand, bounding boxes. So you see the different rectangular boxes here, which basically identify the location of a screw or a hole. And I'm not sure if it's completely visible, but each bounding box has a certain probability as well, meaning that in this box here, for example, this is a 96% probability that there's a screw in here. And here as well. And here we have a 95% probability that there's a hole, okay? So what you clearly see is that, and this is quite typical for machine vision use cases, is that there are multiple bounding boxes with multiple probabilities, and some of them actually overlap, okay? So the algorithm outputs, in fact, these bounding boxes and these probabilities, and of course, the classification on whether it's a screw or a hole. And that is what we process further in the rule of Waylay. So the algorithm is really limited to identifying all of these classifications and these bounding boxes. And in the rest of the rule, we process that further to identify whether, if the process is working as it should, or if there are any issues. And if there are any issues, we basically do here root cause analysis of where the fault could be. And the fault could be that, for example, the screwing machine may need to be readjusted. Okay, if we send, for example, an image that has no screws and no holes, then clearly the entire pipeline is maybe in need of a review. Okay, and that is what you actually see here in the rule as well. We output different alarms depending on the data that is coming out of the machine learning algorithm here, depending on which case we're actually dealing with. Okay. So let me show you that in my demo environment. So this is the templates. So if I take this one, we will make sure that you can also download this template. But here you see it, right? So in a minute, what I will do is I will shoot a particular image into this rule, and this rule will then trigger the Azure ML algorithm to evaluate the image and output a certain alarm. Okay, so let me already start the rule itself, because the algorithm itself, it takes a while to process the image, right? It's about 20 seconds or so to process the image. And then yeah, you will see that certain alarms will be triggered. So let me trigger this one as a reactive task and start that one. Okay. So what we will do is we will basically send this image in the rule, and this image is actually stored on our GitHub account. So you can also download it. This one. So this is the image that we will send into the rule, and clearly here you see that there's one screw missing, and that's also the alarm that that we expect to see. Okay. So what we will do is have it here available in Labs. So here in Labs, I'm going to simulate my camera, and I'm going to simulate that it has captured the image that I showed earlier, and I'm going to send the location of that image inside the message in the rule. Okay, so I'm going to push that. So it just got sent. So so what's going to happen now is that the rule will have received this picture. And here you basically see it, this debug dialog that is executed in parallel. The next step that we do is then transform that data. It's actually quite simple what it does. It takes the message from the camera and transforms it into a format that the Azure ML algorithm expects. Okay, so just very simple. We just put URL here, and this is the location of the image. Okay, so here is the Azure ML node that interfaces with Azure ML, and this is actually the location of our Azure ML endpoint. So here, this is what we what we configure, and the observation is coming out of our transformer script node here that we send in. We enter the content type, and also an API key that is configured on the Azure endpoint, such that we're authenticated and we're allowed to make that call. Okay, so let's see if the rule has been executed. Yeah, in the meantime it has. You also see the state propagation here. So the Azure ML has output that it has processed the data, and it has basically sent the information of the classification to the script node. And the script node, what it's going to do is, it's a quite fancy script node. It's going to look at the classification. It's going to look at the bounding boxes, where the location of the hole or the screw, and is also going to look at the probabilities of the most probable class. And then what we then do is then we look for what is the bounding box with the highest probability, such that we can locate the most likely location of the screw or the hole. Okay. So in the rest of the logic, we are going to evaluate then if something is wrong, whether where the problem really lies, right? The first thing that we're going to do is we're going to check if any screws or holes are found. And this is this equality operator here, where we check if yeah, if we have just a wooden board without any screws or planks. If that would have been the case, then we are dealing with a broken process, and a broken process alarm would be triggered. If that is not the case, but we have some screws are missing, then clearly the screwing machine needs to be readjusted, and we'll generate a missing screw alarms. And that is exactly what has happened. So if we go now to our open alarms, this is the alarm that was just generated a couple of seconds ago. We have missing screws alarms, and we found three screws and one hole. Okay. So this is exactly what the rule has executed. And you see that also here in the debug dialog, maybe a little bit hard to see, but yeah, the actuator for missing screws alarms was executed. Okay. So this is kind of a nice example on how Waylay can orchestrate computer vision and machine learning associated with that. Clearly, Waylay does not store images. The only thing that it stores is time series data, but it can still be of use to orchestrate the whole processing of images using, for example, an external machine learning algorithm that is hosted on Azure ML or on SageMaker, doesn't really matter, and then do the post-processing of those algorithms. So, and in most cases, what comes out of those algorithms are like a classification with some probabilities, and you need to do some post-processing in order to determine, yeah, what you really need to do if something is wrong, right? And sometimes it has to do with the, in our case here, the production process, and you want to do production process root cause analysis here. So this is kind of a nice example on how Waylay can collaborate with external ML platforms. Okay. So I hope that was a bit clear on how that works. Like I said, we also have examples of SageMaker, and we can show you that as well. But I would say, yeah, feel free to experiment with these kind of things. It's actually quite straightforward. Now, the next feature that I wanted to highlight is, what if I don't want to use an external AI framework to host my trained model? And let's say I don't want to use Azure ML to host my algorithms after they've been trained, or I don't want to use SageMaker. You can also use Waylay to host your models, right? So Waylay has a number of algorithm serving capabilities. Again, depending on what you want to do. Obviously, like I mentioned in the beginning, if you have heuristics or expert knowledge that doesn't really need any machine learning, but is more about threshold crossing, etc., you can use the Waylay automation engine to build templates like this, and let Waylay serve that knowledge, that algorithm as a rule. Okay, so in that sense, you can use the Waylay rule designer to design your rule. You can use labs to validate your rule and test it before bringing it into production. And then ultimately, you can also use Waylay's tasks to instantiate these rules and run them across devices. Okay, so the whole life cycle related to your heuristics can be done within the Waylay platform. Similarly, if you want to use Waylay's time series analytics to automatically create a model for your data, then again, you can use the time series analytics designer to design your algorithm. You can choose to let Waylay completely automate the model selection and model tuning, but you can also make manual overrides there. So it does allow for an expert view, I would say, to basically tweak and tune all settings, for example, for SARIMA algorithms or linear regression algorithms, etc. But it's really focused on time series data that is in our time series database. So there again, you can use the Waylay platform to design your algorithm, test your algorithm, and ultimately instantiate your algorithm to run it in the Waylay environment. Okay. What I'm going to talk about next is Waylay's algorithm serving capabilities. In case, for example, you're doing your algorithm design and training in, for example, a Jupyter notebook. Okay, we have customers that are using Jupyter notebooks on their own clusters of machines locally within their own company, or they just do it on their PC because it doesn't really require that much data. But it's done outside of the Waylay environment, okay? And there we offer an API at this moment to upload your model, such that you can then use your algorithm within a rule like this, okay? And I'll dive into that with an example in a minute, okay? We have documented this extensively. So if you go to docs.waylay.io and you go to the API guide, there you will find a new link, which is called Bring Your Own ML Reference. And this API describes how to upload your TensorFlow model, or your trained TensorFlow model, or your Python model. So we use scikit-learn there, or XGBoost, for example, is another type of algorithm framework that we support. Currently, there's no UI yet to upload and manage your models, but you can do it easily from, for example, your Jupyter Notebook, and that's something that I'll show in a minute. So this documentation describes how to upload your model, and depending on what type of model you would like to use, we have specific instructions. You can also provide an example input. You can also do predictions and so forth. So documentation is pretty self-explanatory there on how to use it. It's enabled for everybody, by the way. So if we are hosting the platform for you, you can immediately use it right now. If you have your own environment and you're deploying it yourself, please contact us. We can help you to set it up. It's actually pretty straightforward. Okay. All right, let's get to the example. Okay, so what is the idea? Well, I have built a TensorFlow algorithm on my personal PC. I'm using a Jupyter Notebook to create a TensorFlow algorithm and train it and validate it with some pre-recorded data. The algorithm is really focused on doing predictions of energy consumption based on historical data. So of the past 1 month data, we based on hourly samples, we can make predictions for example, the next week. Okay, so it doesn't really matter what the algorithm is about. You can use any algorithm as you want, but ultimately the idea here is that you have your Jupyter Notebook where you do all your design and your validation, and one of the last steps will be to actually upload that model to the Waylay environment using the API that I just showed you, and then using it inside a rule like this, for example. Okay. For people that are a little bit more technical, the framework that we're using supports a number of different algorithm frameworks. It supports TensorFlow, PyTorch, scikit-learn, and XGBoost. For what we have seen, these four should be usable for you as well. If you have specific requirements around frameworks, drop me a note, and we can definitely look into that. But for now, we support these four. Okay. All right. So let me show you the actual rule. Okay. So what is the rule about? Well, I'll go immediately into the environment here. So let me get back to my demo environment. So TensorFlow example. We'll also provide this this template for download on our GitHub repository. So you can download it as well. So what is the use case? The use case here is that we will pull historical data out of the Waylay time series database. In this script node, we are transforming the data into a format that is understood by the TensorFlow algorithm. Then we forward that data to our TensorFlow algorithm that we host. And this TensorFlow algorithm is going to make predictions, like I said, for the energy consumption of the next week. And we are going to compare those with the actual received energy consumption values, and then compute the root mean square error between the prediction and the actual received values. Okay, so it's a quite simple one. This last node here, the script node, is just computing the root mean square error. And this is where the comparison actually works between the predicted values and the actually received values. And we will output that root mean square error in our debug dialog. Okay. So how does the Jupyter Notebook look like? Well, this is my Jupyter Notebook. Like I said, I'm running this locally on a PC, and I've trained it also locally on a PC. I'm not going to retrain it here right now, but yeah, this is something you can download. I'm not going to go into the details here, but for example, here we create the model. It's going to be an LSTM model, for example. This is the model summary, etc. Here I trained the model. It does take a while before it's trained. And then we save the model, and this is where this is the part that is of most importance here for this webinar, is that we expect that there's a zip file that we can upload to the API. Okay, so in case of TensorFlow, it's going to save the TensorFlow model in a locally on your PC in a certain format, and this format is looking like this. So here I already did it. This is my saved model. So what is in this model? You have a number of variables. You have, of course, the model itself. Then you have some assets here, which is empty, but you have some variables here that it uses to instantiate the neural network and so forth. It's not important what is in here, but ultimately this saved model is what we will zip into a zip file, and which we will upload using the Python code here that is in the notebook. Okay, so here is basically a function that you can just copy and paste into your own notebook, which will upload the model to the Waylay, to your Waylay environment, and give it a particular name and a description. Here we give it a specific model name and a specific description. And here we use the API key and secret to be able to interface with this new API here that we provide. So BYOML.waylay.io models. That's the new API or URL that is available to upload your models, but you have to use your own personal API key and secret. And for those that are not so familiar with API keys and secret, where you need to get them is from here in user profile. You will find API key, and these are my personal API keys, right? So you have to log into your environment, and you can use then these API keys and secret to upload your models. Okay, so obviously you have to enter it here into your Python code, and then you can upload it. Okay, so I already did that. So for example, if I run this code here, for example, it's going to request which models have already been uploaded. So I can actually run that, and this is the output. So it succeeded, and these are the list of available models that are currently available and running on the Waylay environment. Okay, so here you see that the name of our model is Webinar TF model. Okay, and the framework that we use is TensorFlow. So if you use, for example, scikit-learn, there will be something like scikit-learn here as part of your framework. Okay, so this is how easy it is to kind of integrate the API within your own personal Jupyter environment using this Python code. And yeah, like I said, we already have some customers that are using this, and feedback was good. So it's pretty straightforward to use this. But the trick is, of course, to use your own API keys and secret, and that's quite important. Okay, so let's get back to our rule here. Where was I? So this was the rule. So as you will see here in the configuration of this node, we are making a reference to the actual name of the model that we just uploaded. So Webinar TF model is exactly the same name as what we uploaded here. So it's obviously quite important that you use the same name there. Okay. So if we now run it, for example, I can run it as a one-time task here, for example. And the resource is example store, which has energy consumption data for a building. So if we run this, basically what's happening is that we fetch the data out of the time series database. We are transforming it, and then we are feeding that data to our BYOML predict here, which is executing the TensorFlow algorithm that is processing that data. And you saw that it took a couple of seconds before it outputs its predictions. And then the rest of your flow automatically is executed as soon as the predictions are ready. And you saw the root mean square error appearing there in the debug dialog. So I can run it again here, for example. You see immediately the root mean square error calculated. So yeah, as you can see, the root mean square error is pretty high. So the model typically would need to be tuned and tweaked a little bit more. So now you can go back to your Jupyter environment and make some updates to your algorithm and push the updates to your model and to Waylay using this code. Okay. So we're also working on some UI such that within the Waylay environment, you can see which models have been uploaded and so forth. But we decided not to wait on that because we had quite numerous customer requests on making this capability already available. And I think with this Jupyter integration, and this code, you can already go quite a long way. Okay. All right, let's get back to the presentation. So I hope that was somewhat clear on how you can upload your own personal algorithm that you've built. Like I said, in the rule itself, we don't see the source code on how it is executed. We just see the outcome of the algorithm, which was the predicted values. So this is also kind of a nice way to hide the your own personal intellectual property with respect to your algorithm, while still leveraging the Waylay strength in terms of orchestration of the output of your algorithm. Okay. Similarly, if you're using an external platform like Azure ML or SageMaker, if you use that as a machine learning hosting environment, that of course you can also run your algorithm and still use Waylay rule engine to trigger that. Okay, so what are the benefits of the last approach, where we do the hosting of your model? Well, clearly you don't need an additional model serving framework like Azure ML or SageMaker. If you do all your development locally on your own cluster of machines or your own local PC, then it's actually quite beneficial for you to just being able to upload your model, and we take care of the auto scaling of your algorithm. So the way that it works underneath is that we will put the algorithm in a Docker image, and we can scale it up and down based on the load that it has in terms of data being processed of different sensors, for example. And we can take care of that those DevOps capabilities, of those DevOps, I would say, challenges that are associated with that. You don't have to worry about that. Of course, we expect a trained model, so we expect the training of the model to happen outside of Waylay. But as you've seen in the rule itself, for somebody that is actually then using the algorithm, the business analyst, for example, to decide what needs to happen when the algorithm outputs a certain prediction or a classification, or it identified an anomaly, yeah, the person that is actually building this business logic does not need to know the details of the algorithm. So again, this allows the data scientists and the business analysts to easily collaborate in a very easy way. And of course, if you want to update the algorithm, you can do that using the Jupyter notebook, as I showed earlier, but your rule does not need to change. As long as you keep the name of your algorithm the same, if you overwrite it, automatically all of your rules will be automated, will be updated, and you don't have to worry about bringing rules down or anything like that. It's automatically updated for you. Yeah, you have easy access to metadata and time series data. So you can do all sorts of pre and post processing within the Waylay rules engine to feed the right data in the right format to your algorithm. So if your algorithm needs particular features, that is a combination of data coming from your sensors, with features coming from your metadata, with features coming from maybe an external inventory database. Well, it's pretty easy for Waylay to gather that data and then combine it together, enrich it before sending it to your algorithm. So your algorithm can really focus on doing the predictions, and you can use Waylay as the engine to collect your data and basically do the pre and post processing of the data coming in and the data coming out of your algorithm. So such that your algorithm itself does not become bloated. You can really focus on the core algorithm itself, and all the pre and post processing can happen within the Waylay platform, and that will be pretty easy to do. Like I said, we decided to focus on releasing this REST API for the bring your own model right now, because it can also easily be integrated in your CI/CD deployment toolchain. I gave the example of a Jupyter notebook, but as you can imagine, if you have specific scripts that you use internally, then you can easily extend those scripts to also call the Waylay REST API with whatever tooling that you prefer to do the automated deployment of models or do updates of your models whenever there's a new version available. So that makes it quite handy. All right, so there's also a security aspect to it, in the sense that we've protected the API using the API key that I showed earlier. Of course, around API keys, you have a whole role-based access management within the Waylay environment. So only the right person with the right API key can upload and change models, and no one has access to the source code. So you can hide your intellectual property quite well in that way. So there's also no download download API call that you can do to download your API. Just upload and we run it. We don't know what is inside. And we have multi-cloud support, which is also handy, because we have some customers that are actually having teams in the US, for example, building algorithms on SageMaker, and then exporting those algorithms and then importing them on the Waylay environment, while maybe the data science team in Europe is using on Azure, and maybe the team in Singapore is working on their local machines and preferring Jupyter notebooks to do that development. We made sure that our API is completely cloud agnostic, such that you can use any platform that you choose to train and design your algorithm, and then use Waylay as the environment to host and operationalize your algorithm. And as usual, Waylay is multi-cloud, so we can deploy in Google Cloud, or we can deploy in Azure or AWS, or even Alibaba if you want, as long as there's a Kubernetes infrastructure available. So yeah, Waylay can basically run any algorithm, no matter where and which tool was used to design it.